I am so glad you could join me here again at Math Rocks with Mr. Cox for another math video. In this video, we're going to focus on these kinds of problems, the laws of exponents. So for instance, if the bases are the same and we're multiplying, what do we do with these exponents? Or instead, perhaps if we're dividing, what do we do? Or what if we have a power raised to a power? So we're going to be looking at how those laws work with exponents when bases are the same. And then at the end, we're going to be looking at even higher kind of caliber problems where we have a combination of all the different laws in place. So if you want to see how this works, stick around. Let's get it on! So there's going to be a few laws of exponents, and the first one we're going to look at is when we have multiplication. And let's take a closer look at problem A here, and let's just kind of break it down to how you know exponents work. If we have x to the third, that literally just means x times x times x. And if we have x to the fourth, that would be x times x times x times another x. So altogether, because we also have this multiplication here in the middle, we literally have 7 x's multiplied together, which means our answer is going to be x to the 7. So if we're looking for a shortcut here, all we have to do is really just add 3 plus 4 to get the 7. So if we're looking at a more complicated problem like this one over here, a to the 20th times a to the 15th, all we have to do is take 20 and add on 15, we get 35. So this would be a to the 35th. And likewise on this one, all we have to do, because our bases are the same, it will be 42 plus 11 is 53, so this would be b to the 53rd power. The second type looks like this, where we have a power raised to a power. So let's take a look at the first problem once again here, kind of break it down. So if we have x to the 5th to the 3rd power, that means x to the 5th times itself 3 times. And what you just learned from the previous type is that when we're multiplying and bases are the same, all we have to do is add the exponent. So 5 plus 5 plus 5 is 15. So this is x to the 15th. Or you can also look at it as all you had to do at the beginning was take 5 times 3 when you have a power raised to a power. So for instance over here, if we have p to the 8th to the 5th, this would literally be 8 times 5 is 40. So this would be p to the 40th. This one would be 12 times 4 is 48. So that's how it works when you have a power raised to a power, is you actually multiply the exponents. The third type is using division. And so once again, let's kind of break down one of these here. So if we had x to the 6th, that means 6 x's multiplied together. So I'm going to go ahead and write those out. So here they are. And then on the bottom, I would have 2 x's multiplied together. And now what we can do is we can cancel out one of the x's on top, replace it with a 1 on the bottom, because x divided by x, anything divided by itself is just 1. I can do the same thing here as well. So these are 1s. So what I have left is I have 4 x's on the top multiplied together, so that would be x to the 4th, and the bottom is 1, so literally this is just x to the 4th. So the shortcut here would be simply to just go ahead and take 6 minus 2. So if we did that in the next problem, 20 minus 4 would be 16. So that would be the answer. On this one, we're just going to take 50 minus 10 is 40. So our answer here is c to the 40th power. So when we have division, we're going to end up subtracting the top minus the bottom exponent, and that would be your answer. All right, the last type are these special cases here. So on the previous problems when we were doing division, the top exponent was always bigger than the one on the bottom, but that doesn't always hold true. So if we were to follow the rules here, the rule was go and take the top minus the bottom. So if we were to do 2 minus 5, we would get n to the negative 3. So yes, it is possible to have negative exponents, and that's okay. And then the other way to look at it would be if you take n times n, which is n squared, and then on the bottom you have 5 n's multiplied together, here they are, and use the same principle as before, I can cross off each n on top with one of the n's on bottom. And so what that leaves us here is that we have 1 times 1 is just 1, and we have 3 n's together multiplied together on the bottom, so that would be n to the 3rd. So really, if you notice here, if we have n raised to a power of -3, it's really the same thing as 1 over n to the third power. You just change the sign here and do the reciprocal. So once again, if you had something like, I'm going to just make this up right here, x to the -8, that would be the same thing as 1 over x to the 8th power. Well, what if the powers are the same and you're doing division? Well, the rule says what you're going to do is you're going to take 7 minus 7. Well, 7 minus 7 is 0, so that's kind of weird. So yeah, you have d to the 0 power. However, we also know that anything divided by itself in math is just 1. So not only is this d to the 0, but it's d to the 0 and 1. So another principle of exponents is anything to the 0 power, except for 0 of course, will equal 1. So for instance, let's say I made this up right now. I have 5a to the 5th, c to the 11th, and it's all to the 0 power. Anything to the 0 power is just 1.
If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to the show.
All right, next up, I thought I'd just show you a quick little summary of the laws of exponents. So here's the one when you're multiplying and the bases are the same, you're going to add the powers. When you have a power raised to a power, you're going to multiply the powers. And in this case here, when you have division going on, you're going to take the top exponent minus the bottom one. Negative exponents work very similar in that we just have 1 over x to the positive exponent, and then anything to the 0 power except for 0 is 1. So that's your quick little summary of the 5 laws of exponents. And finally, I wanted to give you a chance to look at some more difficult problems. So we have problem A, we have problem B over here. So what I'd like you to do is go ahead and pause the video, try these two problems, see if you can figure out what the answer would be in these more complicated situations. And then in a few seconds, we're going to go ahead and I am going to show you the solutions. All right, let's go for the solutions. First thing you should have noticed is we had a y. Well, that would be y to the first, so make sure you realize that is y to the first power. And what we're going to do is we're going to leave the first part alone for now, so I left that in red here, but let's deal with the second part that's squared. If we were to take 5 and square it, we're going to get 25. The power rule for this would be 11 times 2 is 22. So now we have x to the 22nd, and 1 times 2 is 2. So we have 25, x to the 22nd, y squared. Then you can either do this in your head or actually wrote it out this time is I kind of arranged this so that the numbers were together. So I have 3 times 25 is right here, and that's 75. So that just operates like normal numbers. And then I put the x's together, so we would go ahead and add the exponents. So 22 plus 5 is 27, and then for y, 8 plus 2 is 10, so that would be your final answer. In the second problem, we have 2 to the third power. Well, 2 to the third power is 2 times 2 times 2, so that's why you see an 8 right here. And then our power rule would be 2 times 3 is 6, so that's 8 to the 6. 4 times 3 is 12, so b to the 12th, and then 5 times 3 is 15, so c to the 15th. And now for division, what we would do is on the 8 and on the 10, they're both divisible by 2, so that's how this becomes 4/5. 6 minus 6 with a division would be a to the 0. 12 minus 7 would be b to the 5th. 15 minus 21 would be c to the -6. So once again, either in your head or you could do it on paper like I did here, I just went ahead and kind of wrote these all as fractions. So 4/5 is already a fraction. Well, a to the 0 is 1, and I went ahead and wrote that as 1 over 1. B to the 5th would be b to the 5th over 1. Now, changing this negative exponent into a positive exponent is generally what you're going to be asked to do. So that would be 1 over c to the 6th. And then when you multiply across the top, or the numerator, 4 times 1 is just 4, so it'd be 4b to the 5th. And then 5 times 1 is 5, so it'd be 5c to the 6th. Or if you wanted to use negative exponents, you could write this as 4/5 b to the 5th, c to the -6. But generally, teachers ask you to leave it as your exponents in positive form, not in negative form. So that's it. Those are the laws of exponents. Hope you got a lot out of all the instruction in this video, and hope to see you again soon. Thanks for watching.